hope you are doing fine today. So we will be reviewing some of the topics which are included on the coverage of midterm exam. So particularly, we will be covering problem sets for methods of substitution, which involves the use of first order differential equations. So we will be recalling some of the principles for each given methods of substitution, and then afterwards, we'll have a problem, okay, or a set of problems that we're going to solve, okay, so for each given topic. So we start with the Bernoulli's equation. So there are 5 steps for the Bernoulli's equation. The first one is we need to eliminate. Okay, so we need to eliminate the variable, so other than the q of x. So a Bernoulli's equation should follow this format: the dy over dx plus p of xy is equals to q of xy raised to n. So if the dependent variable is y, so therefore, we have the p of x and the q of x. And then on the right hand side of the equation, so we have this y raised to n. Okay, so y raised to n. And the idea for the Bernoulli's equation is to transform the equation into a linear equation. To do that, so we need to eliminate y raised to n. So that's why our first step always will be to multiply this one by y raised to negative n. So if this one is y squared, so we multiply y raised to negative 2. Okay, so if it is positive, so let's say this is y cubed, so we multiply y raised to y raised to negative 3. So if it is negative, so let's say it's y negative 2, so we multiply it by y raised to 2. Okay, so that is our first step. So that is to eliminate the y raised to n. So we start with the right hand side of the equation. And then afterwards, so we're going to substitute. Okay, so for the second step, so we proceed here. So we're going to substitute for the value of v, but then to transform the given equation into a linear, so whatever would be this y, so whether that is y raised to negative 1, y raised to negative 2, so we let that one as our v. Okay, so that's our second step. And then for the third step, so we multiply the reciprocal of the coefficient of dy over dx to eliminate it. Okay, so meaning whatever would be the numerical coefficient of dy over dx, we need to multiply it by the reciprocal of that. Okay, so as to make this one as just simply dy over dx or dx over dy. So we cannot proceed to the method for linear equation until there is a coefficient, okay, a numerical coefficient other than 1, so for dy over dx. And then, so once we were able to do that, the first, second, and the third step, so that is the time that we were able to transform it into a linear equation. So thus, we solve the equation using method for linear equation. So we determine, so what is the p of x, okay, and then what is q of x afterwards, so after the substitution. And then, so once we were able to determine the general solution of the differential equation, that's the time that we're going to transform it back to the original variable. Okay, so that is, we take our original assumption, so what's the value of v, okay, and then we substitute it so into an x and y equation. So that is for the Bernoulli's equation. So we always start at the right hand side of the equation as our first step. Second, we substitute, okay, so to make it linear. The third, we remove the coefficient of the dy over dx, and then we solve it using linear equation. And lastly, so we transform it back to the original differential equation. Okay, so those are all the 5 steps, okay, so for Bernoulli's equation. So by the way, this is problem number 5 on the reviewer, so I provided, so which is related to Bernoulli's equation. So that's why these are not numbered sequentially. Okay, so we start with problem number 5. So by the way, so this is an example of a prelim exam, so during the second semester of school year 2022-2023. Okay, so with the given problem, so together with the answer. Okay, so we just need to find the solution for this given problem. So we have determined the general solution of the Bernoulli's differential equation. So given we have y to the fourth minus 2xy dx plus 3x squared dy is equals to 0. So to solve this one, anyway, let me move this out to the left. So I have y to the fourth, then minus 2xy, so I multiplied it with dx, then plus 3x squared dy. So we have here, so 3x squared dy. So since that's a single term, that's the one that will be going to the denominator. So thus we separate this one, so by dividing everything by 3x squared and dx as well. So that will yield into, so y to the fourth minus 2xy and divide it with 3x squared. And plus, so we have dy over dx is equal to 0. So now that we have our dy over dx, so I'm going to separate the first term into two terms, but I'll start with dy over dx first, and then it will become, so plus y to the fourth over 3x squared, then minus, so 2xy all over, so 3x squared is equal to 0. So dy over dx then, so plus, so y to the fourth over 3x squared, and then this one, so will become minus, so x will be cancelled out, but then we still have 1 there, so that will lead us to 2y all over 3x will be equal to 0. And from here, so since this is dy over dx, so we should have it as linear in y. Okay, so because this is dy over dx, and out of the two terms here, so we have y raised to the fourth, and the other one is minus 2y. So I'm assuming, okay, or rather I'm sure, okay, so that this should be linear in y. So dy over dx then, so minus, so 2 over 3x, and then multiplied it with y is equals to, so we transpose, okay, so the y to the fourth over 3x squared, so it will become negative y to the fourth all over 3x squared. And thus, it's on the format of a Bernoulli. Okay, so it's a Bernoulli's equation. So therefore, we transform it. Okay, so using our 5 steps. Okay, so the first step is to eliminate, okay, so the y raised to 4. And we can do that, so by multiplying everything by y raised to negative 4. Okay, so y raised to negative 4. So it will become then y raised to negative 4. So multiplied it with dy over dx, then minus, so 2 over 3x. So y times y raised to negative 4 is y raised to negative 3. And then is equals to negative 1 all over 3x squared. So negative 1 all over 3x squared. So we're done. Okay, so the right hand side is purely a function of x. So this time around, so we make this one linear. So to do that, so we need to substitute. So we're going to let, so v, so in this case it's not linear because it's y raised to negative 3. So I'm going to let it to be y raised to negative 3. Then afterwards, we derive this one with respect to x. So dv, so will become dv over dx, then is equals to y raised to negative 3. So derivative would be negative 3. So y raised to negative 4. And then we derive it as dy with respect to x. And then we proceed with the third step. So that is to multiply everything by the inverse of negative 3. So which is negative 1/3. So dv over dx so will be equal to y raised to negative 4 dy over dx. And thus, this is the same as this. So y raised to negative 4 dy over dx is the same as negative 1/3. So dv over dx. So multiplying that, so that will become, so negative, or substituting, so negative 1/3. So dv over dx, then minus, so I'll have 2 over 3x. So we transform the y raised to negative 3 into v. And then it's equals to negative 1 over 3x squared. Then our third step is to eliminate the coefficient of dv over dx. So we can do that by multiplying everything by negative 3. Okay, so we cannot perform the methods for linear equation unless there is a coefficient for dv over dx. So removing that, so that will give us dv. So dv over dx. So negative 3. So negative and negative, so that would be positive. So 2/3, so times 3, it will just become positive 2 all over x times b. And is equals to positive 1 all over x squared. And thus, that makes our linear equation. So next step is to find the integrating factor. Okay, so we proceed with the methods of linear equation. So we find the integrating factor. So the integrating factor so will be mu of x is equals to e integral of 2 over x dx. And then this is 2 ln x. And this is the same as ln x squared. So therefore, our mu of x is just simply x squared. And we can proceed. Our general formula then, so would be mu of x, so times its linear in b, integral of q of x, mu of x dx. So our mu of x is x squared, so times v is equal to, our q of x is 1 over x squared, mu of x is x squared dx. So that's, this is the same as vx squared is equals to the integral of dx. And thus we have v x squared is equals to x plus c. But then, so since this is a substitution method, so we transform it back as our last step, wherein v is equal to y raised to negative 3. But recall that v is equals to y raised to negative 3, or this is the same as y over y cubed. So it will become then as x squared over y cubed is equals to x plus c. So we can now multiply everything by y cubed. So to make this one as x squared is equals to xy cubed plus cy cubed. So for our final answer, so x squared minus xy is equals to xy cubed plus cy cubed. So it would be the general solution for the given Bernoulli's equation. Okay? So let's proceed with our next problem. So this time it's about homogeneous equation. So for homogeneous equation, the process for this one is we substitute. Okay, so whether we're going to substitute it for x or for y, again it depends. So which is less complex. Okay, so we look at the differential. So whichever is less complex. So when I mean which is less complex, that is the function. Okay, so which has lesser number of terms as compared to the other. So if m of x, y has a lesser function, so then we let x, okay, so to be equal to vy. But then if n of x, y has a lesser terms as compared to m, so therefore we use y is equals to vx, so to make our solution less complex. So after that, so once we substituted the x or y, we eliminate, okay, so a term, so corresponding to the degree of homogeneity, so as to simplify more the given equation. Okay. So after eliminating the term, so following the degree of homogeneity of the homogeneous equation, so we separate. Okay, so all homogeneous equations are separable equations. Okay, so once we were able to eliminate, okay, so eliminate the term with the degree of homogeneity, so we separate. Okay, so separating, or this is a separable equation, and then afterwards we solve, and then we transform it back to the original equation. Okay, so that is for homogeneous equation. So we have our problem number 3. So we are asked to prove that the given equation below is homogeneous and determine its degree of homogeneity. So to prove that this is a homogeneous equation, so we substitute. Okay, so we substitute x so all x so will be transformed into lambda x, and then all y's will be transformed to lambda y. So if after substitution we can factor out this lambda, okay, so for the entire equation, and then that makes it as a homogeneous equation. And then the degree of the lambda, or the power of the lambda, so would correspond to the degree of homogeneity. So to do that, so we just transform, or we substitute. So in this case, we have the square root of x cubed times y. So that is x cubed. So lambda x, then raise it to 3. And then y is lambda y. Dx is just simply dx. And then plus, so x is lambda x, y is lambda y, and sine, so y, so should be lambda y, and x should be lambda x. So all x and y's so should be transformed into delta x or lambda x or lambda y. Okay, so we should not leave any x and y without substituting lambda x or lambda y. And after doing that, so we can observe that in this case, so lambda so can be cancelled out. Okay, so lambda can be cancelled out. So we leave that as is. But then in here, we can see that this would become lambda cubed, so which is multiplied with x cubed, and then we still have lambda y, so dx. And then plus, so from here, so I could combine lambda and lambda, so this would become lambda squared, and then multiply it with xy, sine y all over x times dy is equals to 0. And then from here, so since this is multiplied, so lambda cubed and lambda, so we could have that one as lambda raised to the 4th, and I'll have x cubed times y. Then multiply it with dx, then plus lambda squared xy sine y all over x, multiply it with dy is equals to 0. And from here, so we have the square root of lambda raised to 4. So square root of lambda raised to 4, so we can find its square root. So that will make it lambda squared. So lambda squared, then the square root of x cubed y dx, then plus lambda squared xy sine y all over x dy is equals to 0. And as you can see here, so there are two terms involving lambda squared. So I can further move out lambda squared, and that will become square root of x cubed y dx. So plus xy, so sine y all over x dy. So I got that one incorrect. So we now have it as, okay, so dy is equals to 0. And as you can see here, so the original equation is the same as this one. Okay, so which is exactly the same as the original equation. But then, so we were just able to factor out lambda squared. So if you were able to factor out lambda squared, that makes it homogeneous. Okay, and the degree of homogeneity is 2 as the power of lambda. Okay, so degree of homogeneity then so will be equal to 2. If we cannot factor out lambda, okay, so for the entire equation, then that makes it a non-homogeneous equation. But in this case, so since we were able to factor out lambda square, so that makes it as a homogeneous equation, and the degree of homogeneity is 2. Okay, so that is for homogeneous equation. So problem number 4 is a midterm exam problem. We are given xy dx minus x plus 2y squared dy is equals to 0. And then, so we are given an initial value that when x is 0, so y is equal to 2. So this is a initial value problem. We are to find a particular solution. And then it is mentioned that the equation should be free from natural logarithmic functions. So to do that, so we can use the process of lambda, okay? But then as we can see here, so there are two terms. We have this one, this is 1, and this is 1. So therefore for this term, the total degree is 2. Then this is x squared. So this is 2y squared. And then the product, so once we expand it, so it's still 2xy. So x and y would still be 2. So therefore, the degree of homogeneity, okay, so for this given equation or this homogeneous equation is 2. So now we solve this one. So using homogeneous equation, and we can see here, okay, so that m of xy is less complex as compared to n of xy. Okay, so m of xy is less complex as compared to n of xy. As we can see here, okay, so dx is multiplied to x and y only. So unlike dy, so which is multiplied to x plus 2y raised to 2. So therefore, okay, so we let x so to be equal to vy. So thus dx is equals to v dy plus y dv. Then so we substitute. So x to be equal to vy, then multiply it with y. So that would give us, so vy squared. And then dx is v dy plus y dv minus, so x is vy, so plus 2y squared dy is equals to 0. And from here, so we have vy squared, so v dy plus y dv minus, so we can factor out y, so yielding to y times v plus 2 squared dy is equals to 0. And then we have vy squared, so v dy plus y dv, so minus, so we distribute, so that will become y squared, so v plus 2 squared dy is equals to 0. So from here, so we can multiply everything by 1 over y squared. So that would cancel out all y squared, and leaving us to have, so v times v dy we distribute, so v squared dy, then plus vy dv minus, so we expand v plus 2 as v squared plus 4v plus 4 times dy is equals to 0. So v squared dy then, so plus vy dv minus v squared dy. We distribute the negative, so negative 4v dy and then minus 4 dy is equals to 0. So v squared dy minus v squared dy will be 0. Thus giving us to have v y dv, and then we can factor out negative 4. So leaving us to have positive v, then negative 4 and negative 4, so plus 1 dy is equals to 0. So this time, so this one becomes a separable equation. So that will lead us to v dv over v plus 1, then minus 4 dy over y is equals to 0. So this is a separable, or this is already separated, but then we have an improper fraction v over v plus 1. So we can make this one as v plus 1 minus 1, so as to separate it into two terms. So minus 4 dy over y is equals to 0. So this one will become, so 1 minus 1 over v plus 1 dv, then minus 4 dy over y is equals to 0. So we can now integrate as v minus ln of v plus 1 and minus 4 ln y is equals to c. This is the same as v ln v plus 1, then minus ln y raised to 4 is equals to c. Then I transpose the c to the left hand side, so it will become v but still plus c, and then that will become positive ln, so ln v plus 1, and then plus ln y raised to 4. So this would become v plus c, so we can combine the two as v plus 1, so times y raised to 4. So we can exponentiate both sides, so leaving us to have c e raised to v is equals to y raised to 4 v plus 1. But then we have the value of v, so to be x over y. So we substitute. So this would become c e raised to x over y is equals to y raised to 4 So v plus 1 is x over y plus 1. So c x over y is equals to so y to the fourth. So combining the two, this one will become y. So for the denominator, and that would be x plus y. So that's giving us, so c e raised to x over y is equals to y cubed and x plus y. But then since this is an initial value problem, so it says that when x is 0, so y is 2. When x is 0, so y is 2. So we substitute. So c e raised to 0 over 2 is equals to, so y is 2 cubed. X is 0, y is 2. So that's, this would be 0, this is 1, and 2 raised to 3 is 8 times 2, that is 16. So thus our final answer will be 16 e raised to x over y is equals to y cubed x plus y. So we can interchange as y squared or y cubed x plus y is equals to 16 e raised to x all over y. So this would be the particular solution for the given problem. Okay, so which is about homogeneous equation. And that's it. So let's have another one. Okay, so which is about equation with coefficient linear in two variables. So there is a standard form for equation with coefficient linear in two variables. The first one is the m function and the n functions are both linear. So that means the power of x and the power of y are both 1. And then there are two cases. That is to get the ratio of the coefficient. So if the ratio of a sub 1 and b sub 1 is not equal to the ratio of a sub 2 and b sub 2, so then that makes them an intersecting line. So for the intersecting line, so we find then the point of intersection. Then afterwards, so we substitute to the original equation, so to transform it into a homogeneous equation. And after homogeneous equation, it will go to a separable equation, and we find the solution. So for the second case would be when the two ratios are equal. So we let then w, okay, so to be equal to ax plus by. So depending on what would be the coefficient, the common coefficient, okay, so for the two linear functions. So for intersecting lines, so we transform it into homogeneous and then transform it to separable until we find the solution and transform it back to the original variables. Okay, so for case 2, okay, so which is about parallel lines, okay, or for parallel functions, it's just simply transformable into separable equation. Then right away we transform it back to the original equation. So let's have our example. Find the general solution of the given equation. So we have x plus y minus 1 and 2x plus 2y plus 1 is equals to 0. So from here, so we can see that a1 is 1, then a2 is 1 as well. And then, or b1 I mean. So for the second, we have 2 and 2, so it's 2 over 2. So therefore, they are equal. This one is a case 2. So in identifying, so what will be our w? So of course, we let w so to be equal to the simpler term. In this case, we have x plus y. And so x plus y, so would be our w. And then we just simply derive w, so to be dx. Derivative of y is dy. and then we transpose. So dw minus dy then is equals to dx. But then take note here that let's say we have the x plus y minus 1 dx, and then plus 2x plus 2y plus 1 dy is equals to 0. So for this, so since w is x plus y, so this is the same as x plus y minus 1 dx. But then in here, so what is common is 2. So 2 is only common to 2x and 2y, not 1. Okay, so therefore, so when we multiply this, that would be 2 times x plus y, and then we include still 1 there. So we leave it as 1 there. Okay. So for previous solutions of other students, so they are including, or they are multiplying 2 to 1 as well. Okay, so remember that is 1, it's not 2. So we cannot factor out completely the 2 for the entire function. So we can only factor out 2, so 2, 2x, and 2y. Okay, so that's why we leave 1 there. So therefore, when we transform x plus y, so to be equal to w, then minus 1, and then dx is dw minus dy. So plus, in this case, so that will be 2w plus 1. Okay, so it's not plus 2. So 2w plus 1, then multiply it with dy is equal to 0. And we distribute. So we have w minus 1, so dw, and minus, so w minus 1 dy, plus 2w plus 1 dy is equals to 0. So w minus 1 dw, so I'll have negative w and positive w, 2w, so that means that is plus w. Then negative and negative, so that is positive 1, then positive 1 as well, so that would make it plus 2 dy is equals to 0. And thus, so by separation, so we'll have w minus 1 over w plus 2 dw, and then plus dy is equals to 0. So we need the w plus 2, the numerator, so that would be w plus 2, then we minus 3. So plus 2 minus 3, that would be negative 1. All over w plus 2 dw, and plus dy is equals to 0. So this would become 1 minus 3 over w plus 2 dw plus dy is equals to 0. So we integrate. This is w minus 3 ln of w plus 2 plus y is equals to c. So w minus, so ln of w plus 2 raised to 3 plus y is equals to c. But w is x plus y. So therefore, we have x plus y minus ln of w x plus y plus 2 raised to 3 plus y is equals to c. So finally, so we have x plus 2y minus ln of x plus y plus 2 raised to 3 is equals to c. But then, okay, so that's not the case for the answer. So let's say this is a multiple choice equation. So we want this one to be free from natural logarithmic function. Okay, so we just simply transpose. So this would become x plus 2y, then plus c. Then we make this one positive as ln of x plus y plus 2 raised to 3. Then we exponentiate both sides. So this would become c e raised to x plus 2y is equals to x plus y plus 2 raised to 3. If you want to interchange it, that would be okay as well. X plus y plus 2 raised to 3 is equals to CEX plus 2y. Okay, so this would be for our final answer. So x plus y plus 2 raised to 3 is equals to c e raised to x plus 2y. So that is for homogeneous equation, that is case 2. So let's have another problem. And so based from this one, so I'll have, this is 1 over negative 4. Is it equal with, this is 4 over 1. So as you can see here, so negative 1/4 is not equal with 4. So therefore, that makes it as a homogeneous or linear in two variables case 1. So our first step here is to find the point of intersection. Okay, so to find the point of intersection. So to do that, so I'm going to rewrite the equation. So into, so x minus 4y minus 9 is equals to 0. So the second one is 4x plus y minus 2 is equals to 0. So I want to determine what's the value of x first. So therefore, I'm going to just rewrite the first equation as x minus 4y minus 9 is equals to 0. So for the second equation, so I'm going to multiply everything by 4. So I'm multiplying this one entirely by 4, so that makes it 16x. And then plus 4y, then minus 8 is equals to 0. And we're going to, okay, so we're just going to simply add the two equations. So x plus 16x is 17x. And then negative 4 and positive 4y, that will be 0. So negative 9 and negative 8, that is negative 17. So therefore, so 17x is equals to positive 17. So therefore, x is 1. So since x is 1, so I'm going to use the second equation. So that is 4x plus y minus 2 is equals to 0. I'm going to get for the value of y, so that would become 2 minus 4x. So 2, 4, x is 1. So therefore, y is 2 minus 4, that is negative 2. So thus, we can now let our x, so to be equal to u plus 1. So making dx to be equivalent to du. And then y to be equal to v minus 2. So dy will become dv. So we now substitute to the original equation. So x minus 4y minus 9. So I'll have x, so which is u plus 1, minus 4y minus 4. Our y is v minus 2 and minus 9. Minus 9, so dx is du. The next is plus 4x plus 4. X is x is u plus 1, 4x, then plus y minus 2. Plus y is plus v minus 2 plus minus 2. So dy will become dv is equals to 0. So we simplify. So u plus 1, so minus 4v, then plus 8 minus 9 du. So plus, you distribute 4u plus 4 plus v minus 2 minus 2 dv is equals to 0. So our objective here is to make this one as homogeneous. So therefore, the constant should be cancelled out. So 1 plus 8 is 9 minus 9 is 0. So 4 minus 2 minus 2, that will be 0. And that's so leaving us to have, so u minus 4v du, and then plus 4u plus v dv is equals to 0. Next, so since this is a homogeneous equation, so we transform this one into a separable. So by letting again, so in this case, I'm going to let u to be equivalent to zv. And then du will be zdv plus vdz. So this homogeneous equation, degree of homogeneity is 1. So u is zv minus 4v, so du is zdv plus vdz plus 4u, so that is 4zv and plus v dv is equals to 0. So we can factor out v here. So v, that is z minus 4, so zdv plus vdz. We can factor out v as well, so 4z plus 1, so dv is equals to 0. So we could multiply everything by 1 over v. So since this is homogeneous, so degree 1, so cancel out v. So leaving us to have the z minus 4 zdv plus vdz, and then plus 4z plus 1. So next is we combine. So we combine, so z minus 4, then multiply it with zdv. The other one plus z minus 4, multiply it with vdz. Then plus 4z plus 1 dv is equals to 0. So we have two dv's there. So that would give us, so we distribute, so z times z is z squared, and then negative 4z, then we have positive 4z plus 1, then we have dv. So plus z minus 4 v dz is equals to 0. And as we can see here, negative 4z and positive 4z will be 0. So leaving us to have z squared plus 1. So dv plus z minus 4 v dz is equals to 0. So separating the two, so dv over v plus z minus 4 over z squared plus 1 is equals to 0. So we can now integrate. So to integrate this, we can separate the second term. So dv plus v, this is the same as z all over z squared plus 1 dz, then minus 4 z squared plus 1 dz. So from here, so this one, so we have u as z squared plus 1. So therefore our du would be 2z dz. So making our neutralizing factor so to be 1/2. So for the second term, so this one resembles inverse trigo. So our u squared is z squared. So our u will be z. So therefore our du is dz. Our a squared is 1. So a will be 1 as well. So thus we can now integrate this as simply v, then plus 1/2 ln of z squared plus 1, and then minus 4, okay, and then the integral of dz over z squared plus 1 is 1 over a, so a is still 1, then arctangent of u over a, so which is just simply z is equals to C. And then, so we can multiply everything by 2. So giving us a 2v plus, or sorry, this is ln v. Okay. So 2 ln v plus ln of z squared plus 1. So minus 8 arc tangent of z is equals to c. So this is ln v squared plus ln of z squared plus 1 minus 8 arc tangent of z is equals to c. Then we can combine the two as ln of v squared, so times z squared plus 1 minus 8 arc tangent of z is equals to c. But then we transform it back, so u is equals to zv. So but u is equals to zv, so therefore z is equals to u over v. So ln then, so v squared, so z squared will become u squared over v squared plus 1 minus 8 arc tangent of z, which is u all over v, is equals to c. So this one would become ln of v squared. So we can combine this one as v squared, so u squared plus v squared. So minus 8 arc tangent of u over v is equals to c. So we cancel out v squared, so leaving us to have ln of u squared plus v squared minus 8 arc tangent of u over v is equals to c. But then, so we have the value for u and v. So in here, so we could have that u is x minus 1 and then v is y plus 2. X minus 1 and v is y plus 2. So finally, so we'll have ln, so u here is x minus 1 square plus y plus 2 square minus 8 arc tangent of x minus 1 over y plus 2 is equals to c. And that is our final answer. And that ends the part 1. Okay, as a review for methods of substitution. So using first order differential equation. And so try to see the second part of this video after. Good day. God bless.